For this one, we notice that we have a hydrocarbon, and we're in the presence of oxygen, so that means we're burning oxygen. That's combustion. Here we have a combustion. These are the easiest ones to predict. Okay, very easy. The only issue here is balancing. Sometimes they can be more of a bear to balance, but they're very easy to predict. Because all we have to do is write, it's always the same thing, water plus CO2. Water plus CO2, and it doesn't matter what, or you can write CO2 plus water, it doesn't matter. Okay, we always get the same thing, and now we just balance. It's actually pretty easy. It's just a balancing problem now. Right away, I'm going to put a 2 here to balance those hydrogens, but also make it an even number of oxygens on the right side. So we have 4 hydrogens on the left. Put a 2 here to make it 4 oxygens, and 4 oxygens, 1 carbon, that's balanced. This one on the middle one, we have, now this is separated, but in this case we can just consider this, and if you want you can just do this for the time being, make this 4 hydrogens because that's what it is, and then take it away later. Because we have 4 hydrogens there, we'll make that 4 hydrogens, and we have 3 oxygens on the left side, and we have 4 oxygens on the right. Okay, so I have 4 hydrogen there, 4 hydrogen. 2. Now the issue here, there's going to have an odd number. I'm going to just put a 2 here. It's going to be an odd number of oxygen, so I'm going to put a 2 here to get 4 oxygen on the left side, and I have the oxygens are balanced. But if I put a 2 there, the hydrogens, it comes out to be 8 hydrogens on the left and 4 hydrogens on the right. So I'm going to have to put a 4 here. So that makes it 8 hydrogens on the right, 8 hydrogens on the left, 2 carbons on the left. I'm saving the oxygen for last. That's the most simple of them. I'm going to put a 2 carbon here. So that makes it 2 carbon on the right, 2 carbon on the left. The oxygens on the right will equal 4 oxygens with the water plus 4 oxygens with the carbon dioxide. That's 8 oxygens. And then I'm going to put a 4 here. So let's see if this is balanced. Okay, the carbons, there's 2 carbons on the left, 2 carbons on the right, 8 hydrogen on the left, 8 hydrogen on the right. Oxygen's the only thing left. There's 2 plus 8. Whoops, you know what? Wrong. This should have been 3. So I forgot about the one over there. So that's 6 oxygens on the left. 6 plus 2, that's 8 oxygens, plus 4 oxygens. That should be balanced. Okay, and I can just bring that back. And there we go. Next one. Looks like it might be pretty difficult. It has a C5 here. Let's just automatically put a 5 there. And we also have H9. Now I see that the odd number of 9s, there's an even number of, odd number of hydrogens there, even number of hydrogens there. So I'm not going to even mess around. I'm going to multiply by 2. Now I can multiply everything out by 2, or just that by 2. And then I'm just going to get rid of this 5 here. And that's going to make it a 10C. So the hydrogens are balanced. Excuse me, no, the hydrogens are not balanced. We're going to have to multiply that by 8. We're going to have to multiply that by 9 to get that balanced. Now the oxygens, we're lucky we have 1 oxygen here. We're at 1 lone oxygen, or a pair of oxygens. So let's just then balance the oxygens. 2 oxygens here plus, so that's going to be multiplied by 2. How many are on the right side? Because we're going to leave this, that's going to be our final determinant. That's going to be 9 oxygens plus 20, 29. Alright, so, but now we have an issue because we have 29 oxygens on this side, and we cannot get a 29 oxygens by multiplying anything by 2. Plus we have to add 2 oxygens over here. This is going to be a bear of a problem. I just randomly picked this, but I'm going to show you a little other trick. Now, so I noticed that there's 29 here. Now, remember, I can always reduce later if I have to. And there's 2 here. So I'm going to put 29 over on this side. Or how about, 27 over 2. Because that is actually balanced now. Might not seem it, but 27 over 2 multiplied by O2 is balanced, because the 2's here basically will cancel out. But we can't just leave it like that. So what we do is we multiply everything through by 2. So just multiply 2 by everything, and we'll get rid of this little fraction. We're going to have a bear of a balance here. So 2 times 2 is 4. 2 times 27 over 2 is just 27. 2 times 9 is 18. And 2 times 20, or 10, is 20. Now, the key is, does this balance out? The carbons, that's 20 carbons on the left, 20 carbons on the right. Okay, carbon balances. 4 times 8, that's 30, 4 times 9 is 36 hydrogens on the left, and then 18 times 2 is 36 hydrogens on the right. The hard part is oxygen. How many oxygens on the left? 4 times, that's 4 plus 27 times 2 is 54. That's 58 oxygens on the left. What about on the right? 18 oxygens here plus 40 oxygens. That's 58 oxygens. So this is balanced. That was a doozy, and let's see if we can reduce this. But there's nothing that has a common multiple between all of these, the 20, the 18, 27, and 4. So that's the final balanced equation.